So this is the third update of the SmartyKit build series. It's probably the last update for the build. Probably do a few more videos after this about other things. But I'm done with this part of it. It's up and running. It's working. Overcame a few issues that we had in the previous. I was about to say the previous episode. In the previous update, I had spoken more about wiring up this part and the problem we had with the bridge board, the address and data bridge board having open circuits. So I had put this in, and if you look at the very first update, you'll see that that was just getting the screen up and running. And I called that a dumb terminal in the beginning, and it's not quite the right thing to have said, because it's while this was working on its own at the time, it was hot-wired essentially between the data lines. These data lines were hot-wired directly across. Anything you were typing through the keyboard was going directly to the display driver and going on the board, which is on the display, which is essentially a dumb terminal. But actually, when I came to the next part of the part of building this and building up this part of the circuit, all of the jumper wires across here were removed. And then, of course, it makes much more sense that you've got two port drivers over here, a keyboard driver and a video, or keyboard port and a video port, that is controlling the data flow between the keyboard and the display. About building up this part of it, and that all went well, and I could see that the display then worked and everything was good from there. You'll see that this part over here is a bit of a bird's nest. I'll come to that in a moment as to why. I'll probably neaten that up so that it looks a bit like this, but there's a reason why that's a bird's nest. So let's switch it on. What I'll do is I'll just zoom in on this part of the screen so that you can see things better. Okay, there we are, zoomed in. So if I switch the machine on, the screen boots up, and then what you're seeing here is the boot process of the actual video driver, and not the CPU. Now, in the previous versions, you would have seen the ASCII art of Steve Jobs' garage coming down here, which I just took out because it just speeded things up a bit. But one of the things that's not happening, and it might be something to do with that, and it might be something to do with a bit of wiring, is that once this is booted up, the main processor is supposed to come through and say, "Hey, here I am," which is not happening. So I'm just going to reset the main processor a bit, and then you'll see the display come alive again. So there we are. It starts off by displaying the character codes, and SmartyKit is ready. That's there. So I'm just going to grab the keyboard, and you won't see me typing, but we'll get it in there. So part of the Apple One ROM has got a couple of functions in it that handle the monitor and things like the tape drive. And display and things that are built into the ROM, obviously. But there's also 3 little mini programs that you can run to put stuff on the display. And the first one is application F. Not that many Fs. That's too many Fs. F000, and R for run, and that will bring up a bit of pixel art or ASCII art for the Woz's head. And you see that coming out all right. There you go. The other one, I need to reset at this point. The other one is FC00 and run. And that brings out a heart. And the other one is at FD00 and run that and get a hello world. This is SmartyKit, which is not part of the original ROM because obviously SmartyKit wasn't around then. But it shows you that it's working, and it shows you that the processor is processing, and it's accessing memory and going through the ports and displaying stuff. So that's all good. The next part, let me just zoom back out of here. So the next part of it is the RF art, sorry, not RF, composite video art. And this is where the bit of bird's nest comes in, because I couldn't get that to work in the beginning. And it turned out, for me anyway, there were 3 problems that I had to figure out. Let me just switch the light back on here. Okay. So it turns out there were three problems. The biggest problem is that these Atmel boards, and they're all the same, these three boards are all exactly the same, is defective. And SmartyKit is aware of this, and I believe, well, I've been told they're going to send a new one out. So if you do a continuity test between D0, D1, and D2, you'll find that all those three are shorted out. And that means that the data coming out of port C, is it port C, port D on this, will not work because these three are shorted out. So you'll never get a proper RF data out. The screen itself will work because it's self-contained, and this chip over here, which is the high-res driver that generates the sync signals and so forth, and shifts the information out to the shift register, which then puts it out into the data line. That part of it will work, but you would get some correct information because the first three bits would be shorted out. So you'd always get a 111 on the first three bits. And of course, so you just get junk on the screen. But I wasn't even getting that at the time. This was the first thing I noticed was something wrong. I started, because of the issue I had with this, I started doing continuity testing on all the boards just to check, when something wasn't going right. And actually, it turns out that all three of these boards have the same issue. All D1 through D3 are shorted out. It doesn't pose a problem on these boards because those ports, if you look here, these ports are not used. And so you don't notice it. Although actually, interestingly enough, the clock line on this one is used. But evidently there's enough going out there. But the fact that all three of these have the same mean is probably not a manufacturing problem. I would guess that there's a line that's been routed through this. But then again, looking at the tracks on these boards, and I don't know whether you can see how well you can see that. It's not focusing very well. Yeah, it's not going to focus on that. Let's just try a zoom on that and see if I can get it to focus. Yeah. So if you look at that, you'll see that the tracks, like there's two thin lines. It looks like there's two thin lines going from side to side. And that's what tracks look like when you CNC these things out, rather than etch them. It's the same on this one here. Which is a bit odd. I don't know why it's done that way, because you wouldn't, if you're going to mass produce these things, you're not going to CNC them. It just takes way too long. You would get them etched properly. So I don't know what process they used for that, or why they've done it that way. But it might be part of that the tolerances aren't good enough, and there is a manufacturing problem there, or there's a track that runs through. I mean, I've done this before, where I've routed a track through a pin that it shouldn't go through, and I haven't checked the DRC. But yeah, so it's a bit strange. But anyway, as I say, they are aware of it, and they're going to send me. I've been told anyway they're going to send me a new one, and I'm hoping they'll send a new one to everybody else. But I'm impatient, and I wanted to get the composite art working. So I just mapped. It's pretty easy just to map this out where these data lines are going, and then just rewire it up myself. So that was the one thing. Got that working. But the other thing, which is not in the instructions, I discovered, or having looking through the Discord to some earlier posts from quite long ago, is the basic video trip. It sends 2-wire data through these two lines up to the high-res chip. And if we look at the GitHub under control drivers here, you've got this one here, which is called the video driver basic for the TFT and TV. And if you go into that and go to, you'll see over here that they have this undefined, and they've commented out the define. And what that means is that, as it says here, it turns the TV out off. So of course it'll never work because it doesn't ever generate it doesn't include the terminal header, and it doesn't send any data off to the terminal header. And so I picked this up from the Discord in a previous message, and so that was easy enough to fix. And in my copy of the code, I've commented that out and uncommented that, and that should work. But I was still getting a rather strange scenario when I put the new code in here. The keyboard would stop working, and nothing would go to the screen, or it would hang anyway. It would look like it would hang. And after probing the lines with the logic analyzer, I realized there is no data coming out of here, and there was no data coming back in. Well, the data was going into the processor, but there was no data coming out of here. And then having a look further through this code, if you go and look at the terminal, if you get to this bit here, which is the send to wire, the I2C side of things, it sets a start, and then it waits for a response. And therein lies your problem, because if you don't get a response, you sit in an infinite loop. There's no timeout here. There's nothing over here to say it's not working. So, of course, this processor crashes or hangs at that point. It's in a terminal loop. It can't do anything. So the code really should have a get out clause over here. And you look further down, the same thing there. It could get stuck there and could get stuck there. So that's the place that needs to be improved in the code. But what that led me to was, if this bit of code is working and is waiting for a response and never getting it, then the problem is with the main driver. And so having a bit of a look around that, which is in here. Now, this is all machine code. If you go into the main machine code, if we go down. Okay, so we've got these config lines that come in. We've got a config byte, and it's looking to see if things are high or low as to whether you're setting 80 characters per line or bold, and so forth. But if you carry on down to the two wire side, over here, it grabs from the config byte at this position a value, and it expects that to be low in order for in order to select the 2Y mode. Otherwise, you're selecting 4 or 8-bit mode. And if you go and look for where this is set, which is in definitions, over here, you can see that it is bit 5. Yeah, it's bit 5. And so what happens is that when this is booting up, what it does is it reads the data lines over here, sets them to input, has a read to see what's on there, and then that is a config. And once it's got the config, it sets that to output and sends out. So what was showing there is that actually that value was for D5 over here was actually high rather than low. And if we go back to the SmartyKit instructions, this is D5 over here with a resistor, and you'll see that it's being pulled high. So according to this layout, the 2Y interface is never selected. And because it's never selected, it never responds. And because it never responds, this video controller just hangs up. So that was an easy change, and I just needed to move the resistor here onto the negative to put it low. And then it all started working. And you get an output display, which looks like a bit like this. Now, excuse the is not that clear on this screen. I've got a composite capture module plugged into it, and it's not doing a fantastic job of capturing the composite monitor. But there it is working. It was absolutely wonderful to see that coming up. As I say, if we do F000, not those zeros, those are the wrong zeros. F000 and run again, we get the was up. But this is the other thing about these resistors, because if we go back to the code again, you'll see that the whether it's 80 characters per line or 40 characters per line is done by line 4, which is a bit further up. And if you look at, I've got a resistor in line 4 over here. It is kind of relying on the idea that this is pulling it in the right direction, which it may or may not be doing. And I don't know why they haven't set this up to have proper input lines here, proper inputs here, so that you can see what you're doing. But I can demonstrate this. At the moment, it's pulled low for 40. But if I change that and I pull it high and go back to my composite view, then you'll see you get an 80 line display out of that. So I think it's a bit risky not to preset these, and possibly I should go back here and just set single height and actually just set all these bytes with the resistor so that I know that they're definitely being set correctly at boot. And it gives me the option then to change it as I wish. So yes, we've got that up and running. There were 3 different issues there. Had to do quite a lot of scrolling through both ordinary C code and machine code to see what was going on and why it wouldn't work. But that is half, for me anyway, it was half the fun of doing this. But I think, if they want to get this into all the schools and they want to try and appeal to the younger crowd, then they're going to have to fix this, because an 8 or 9-year-old is not going to know, probably, who knows, is probably not going to know how to fix it, and it's just going to be frustrating. I've certainly seen other people on the Discord battle with this. Hopefully I've managed to help 1 or 2 out with my information I put on the board about this. But yeah, I think they're going to need to sort that out. Next steps on here, I think, will be doing some programming on it, which will be quite fun. At the moment, with just the monitor in it, there's not a huge amount you can do. Well, I mean, you could do any programming you want, but you have to hand compile the machine code and you have to type it in byte by byte, which is fine for small programs. I mean, very small programs, but it's not really sustainable for anything else. The Apple one had a tape deck interface, and you could load BASIC and other things off there. So I think the next stage for this project, if SmartyKit don't do it, then if I get time, what I'd like to do is build a tape interface. I could do it with an SD card, and I might have to do it with an SD card with another Atmel chip or some other chip feeding into another port here. I'd have to get another breadboard out and get another port coming in so that I could feed into the processor. The ROM should have the code in it ready to read from tape deck, and so that could probably work as well. I could mimic that through an Atmel and an SD card. But that at least would allow you to load BASIC onto it, and then you could program programs in BASIC, and you could probably have a lot more fun. So there we go. It's been a lot of fun. It's done. I'm just going to neaten up this bird's nest over here. So if this is the kind of thing you enjoy, then certainly go and buy the kit. I think it's a lot of fun, and it's a great thing to build up. A nice project to do. So I hope you enjoyed the series, and don't forget to subscribe as always, and like if you like, or put a comment if you don't like something constructive. And we'll see you in some future videos. All right, bye.